Hey guys, first of all, I wanted to apologize about the blue box on the screen. Unfortunately, I can't get that taken off because I'm sharing my screen with you. So we'll just have to deal with that. But we're going to start today with our first lesson for geometry. This will be for Monday. That will be Monday the 6th of, or excuse me, the 6th of April. That is when we were due to come back to school. So we're going to go ahead and start our lessons on the 6th, or excuse me, the 7th. So this is for Tuesday, April 7th. This will be our first at home online lesson. So hopefully we'll be able to kind of navigate through here what we need to do. I took a look at our book and where we are as far as how far we've covered and the material that we've covered. And I've basically decided we're going to cover about one more chapter. And then we're going to go ahead and start studying for our final exam, and we'll end it out with our final exam. Truth is, if we stopped right now, I'd be happy with the amount of information that we've covered up to this point. I feel like it's adequate enough to where I could just give you your final exam and close out the class. And we will probably do that a little early this year, so we won't be taking this one when we take the other final exams. But today we're going to work on lesson 5.1. Okay, this is on page number 234. We're going to start off with this lesson on surface measurements. And this first lesson, 5.1, we're just going to kind of read through it. I'm going to point out a couple of things, and then we're going to move forward into lesson 5.2, where we cover some different theorems and things like that. So go ahead and take your books, turn to page 234, and let's start here at the top. It says, any plane surface may be measured by selecting some unit of surface and then determining the number of times this unit is contained in the given surface. The unit of surface most frequently used is a square whose side is of unit length. If this unit length is 1 inch, the unit of surface is a square whose side is an inch, called 1 square inch. If the unit of length is a foot, 1 yard, etc., the unit of surface is 1 square, 1 foot, 1 square yard. 1 square foot, 1 square yard, etc. So we're talking here about surface measurements, okay, and how we can take a unit and measure it by squares, okay, and each square the unit of measurement for the square can change depending on what is the most common unit in the numbers you're dealing with, okay. We'll see some examples here. The area of any plane surface is the number that indicates how many square units of a given kind it contains. Okay, if you look at your book there on the side, it's kind of giving you a little description of this and what this means. Okay, if the rectangle ABCD contains the square U 12 times, then the area of a rectangle in terms of U is 12. That is, rectangle ABCD is equal to 12U. So basically what they do is they take this rectangle and they break it down into units, which they've called U here. And in this in this rectangle of ABCD, they have 12U. And so they measured the size of this rectangle by the unit here, and there's 12 of those units, so that's how they know that ABCD is equal to 12U. Okay, so basically we can take any surface area and we can break it down into measurements, square measurements of certain lengths or certain sizes. Okay, look at your equal figures. Two plane figures are equal if they have the same area, irrespective of their shape. Okay, and some texts use the word equivalent in the same sense as the word equal. So if you see equivalent or equal here, it could mean the same thing. All right. It follows from the definition of congruent figures that congruent figures are equal, and we've talked about this before. Equal figures are not necessarily congruent. So if they're two congruent figures, then we know that they're also equal. But if they're equal figures, that does not necessarily mean that they're congruent, okay? And we've talked about that previously. I know we're going to have to do some warming up here since it's been a while since we've actually had class, so just try and hang in there with me, and we'll try and bring us back up to speed here. If ABC is a rectangle, and if triangle ADC is transferred to position BEC, and they have a little diagram there in the book that you can take a look at, then triangle ADC and ABC are congruent. Also, triangle AEC and rectangle ABCD are equal but not congruent. Okay, so just kind of breaking that down, how things can be congruent and always equal, but they can be equal and not always congruent. Okay, so and like I said, we've talked about that before. Let's look here at this example 1, and they're basically going to break down this process of how we can take a surface and break it down into square units of certain sizes in order to measure what that is. Okay, so let's look at example 1. It says find the area of a rectangle whose base is 5 inches and whose altitude is 3 inches. So I'm going to bring up my whiteboard here, and I'm going to draw this out for us to see. Okay, so we have this rectangle here. Oh, look, my drawing is about as pretty as it is on the whiteboard at school. Okay, and in this rectangle here, the base is 5 inches, so we have 5 inches here. And then we have the altitude. The altitude is your height, okay? So your altitude then is 3 inches, okay? Since 1 inch is the common unit of measure of AB and AD, a square 1 inch on a side that is 1 square inch may be used as the unit of measurement. So what they mean here is you have to look at your units of measurement here, okay? So we've got both of these is dealing in inches, all right? Whole inches. In some cases, you'll have quarter inches. In some cases, you'll have half inches. But in this particular case, both of our units of measurement deal in inches. So we're going to use our box, and we're going to call this 1 square inch, okay? And we're going to measure the surface area of this rectangle by measuring how many square inches are inside of this box. In other words, we would mark this off, and obviously mine is not to scale here, but this, you get the idea. We would mark these off, and then we would count how many different squares there are, and then that would be how many square inches are in this rectangle. So they use here in example 1 a 1 inch square unit, okay? So they use the 1 inch square to determine what the actual surface area of that is by measuring in 1 inch square, what's the term? Units all the way around that rectangle, and they count how many is inside of that rectangle of 1 inch units, okay? So that's example 1 there. Now we know that when we're talking about the area of a rectangle, everybody knows that the area of a rectangle, to find the area of a rectangle, the formula is A equals length times width, okay? So we know that we can take those measurements of 3 and 5, okay? So we can take 5 times 3, okay? And that would obviously give us our 15 without having to count the little boxes that are inside of that thing. So we can use this formula to find the area, but we're talking about here surface measurements, so we want to know how to deal with these units of measurement when we're talking about finding the surface there of any kind of a shape, really. So that's example 1. We have to look first at the unit of measurement that's common between the two measures, okay? And then we have to assign the size of our square unit, all right? Whether that's, in our case, the first case there, they were 1 inch squares, or if we look at example number 2, we have find the area of a rectangle whose base is 3 1/2 inches and whose altitude is 2 1/2 inches. Now here's the difference with this. Okay, if I have a rectangle here, okay, and I have, let's see, we said our base is 3 1/2, okay, and 2 1/2. All right. Now, if I use 1 square inch measurements, okay, the problem with that is I'm going to have this half left over. Okay, so what I need to do is, since the common unit of measurement is half here, instead of using a 1 inch, I'm going to use a 1/2 inch. Okay, now here's the deal with this. When I'm talking about a 1/2 inch square measurement, what I'm talking about is I have a 1 inch box. Okay, so this here is 1 inches. Excuse me, 1 inch. Okay. A half is going to be a 1/2 square inch, okay? So this is actually, okay, this is a 1/2 inch. This is actually 1/4 of an inch, okay? So when I'm using a 1/2 inch measurement, okay, if 1/2 inch is my common unit of measurement, I'm actually talking about a 1/4 square inch, okay? Because this 1/2, we're talking square, 1/2 is 1 of my 4 inches. All right. I hope I explained that appropriately. But when we're talking about 1/2 inch measurements, it's actually 1/4 of a square inch. All right. Now, the same process will take place. Okay. We still have our base, okay, which is 3 1/2, and we have our width, which is 2 1/2, excuse me. And I'm still multiplying those together because remember my formula is A equals width times length. So I'm still going to take these and multiply them together. So I have 2 1/2 times 3 1/2. Okay, if I multiply those together, I would get 8 3/4. And then I would turn that into an improper fraction, which would be 35 over 4. Okay, so this would be my answer for this rectangle that has a base of 3 1/2. Did I do that right? Base of 3 1/2, and then the length of 2 1/2. Okay, so my answer would be 35 over 4. Okay, now here's what we need to understand. There will be times when we will have measurements, and like for instance, if I used the 1 inch measurement when my common unit is a 1/2 inch. If I go down in measurement, I can cover all of that extra space and have even numbers. Does that make sense? So in other words, if I went with ones, I would have an answer plus a half left over, okay? So I would have to take it down, take my unit of measurement down. That way I could accurately cover all of the space there by using a smaller measurement. All right. And the smaller my measurement I go, the more accurate I'm going to be. Okay. That's the main point there is we want to use the smallest common unit of measurement when we're doing these. Okay. Now, if we look at example 3, find the area of a triangle whose base is the square root of 3 inches and whose altitude is the square root of 2 inches. Now, here's the problem here. There is no common measurement, okay? So we can't, we're not looking at, in other words, let me write this out for you. If I have these two measurements here, my base, which is the square root of 3, and my altitude, which is square root of 2, okay? I can't really, there is no common unit of measurement here, all right? So what I'm doing is I'm still multiplying, okay, just like we were doing, fulfilling the formula, okay? And if we remember algebra correctly, we can just multiply these numbers together, which gives me the square root of 6, okay? So I would then get the square root of 6, which would be 2.44948, blah, 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 okay? Now, this is what I mean by this. This does not have this does not have a whole number unit. In other words, my answer is not in whole number. It's so small, the remainders are so small that I can't find a unit of measurement without going ridiculously tiny. That would give me something that would match this with whole numbers, okay? So in this case, we get what we get there, all right? Anyway, so those are basically the breakdowns there of those different exercises, their examples there on the page. Look at the bottom of page 235. And by the way, I know some of this is you can't ask questions while I'm doing the lesson, stuff like that. If you're sitting with your notebook, make some notes if you have questions, and I'll try and answer them. But I'll let you know what's really pertinent information that you have to understand. And then, if there's something that slips a little over your head, I can try and answer it for you differently that maybe you would be able to understand a little better. But I will make sure that we're prepared and know what we need to know for the tests and quizzes and have the information down properly for that. So don't freak out since you can't ask questions while I'm doing the lesson and things like that. You are more than welcome to text me when you watch this and ask questions about it at that point. But some of this stuff is just a broad overview of understanding surface measurements and things like that. And then we'll get into some more information that's a little more pertinent for the direction that we're heading in. But look at the bottom of page 235 under example number 3. It says if the sides of a rectangle have a common unit of measure, as in example 1 and 2, then the number of units of area is equal to the product of the number of units in the base by the number of units in the altitude when each is expressed in terms of one side of the unit. Okay, meaning when I have a unit of measurement and I'm using the proper unit of measurement, and there's that common unit there and I'm using that, I'm going to break that down to where I have the proper amount of square units inside that rectangle to come out evenly. Okay, in other words, I'm not going to have like 23 and then 1/16 of a rectangle left over. Okay, those unit of measurements will all come out completely equal, and I won't have any remainders left over, so to speak. I hope that was understandable. Turn to page 236. Okay, top of the page there. If the sides of a rectangle have no common unit of measurement, like we saw in example 3, it is evident that by making the side of the unit square successively smaller, the successive number of units of area grow constantly closer to the product of the number of units in the base by the number of units in the altitude. In other words, like I was saying before, we can break down our square units into such small square units that we could actually cover a number like we had 2.44948, blah, blah, blah. Okay, I could find a unit of measurement that's small enough so that I would come out with whole numbers there. But it would be a small unit of measurement, which is not in our use of it. It would be more work than what we would need to do. So keeping that in mind, in other words, if I'm using half units, okay, and I have a chunk left over, well, as I take my half unit down, say a fourth, then I have less of a chunk left over. If I take it down to an eighth, then I have less of a chunk left over. If I take it down to a fourth or to a 16th, I have less of a unit left over. So the smaller I take my unit down, the smaller the leftover is until I find a unit that matches identically with that, okay? So that's what that means. Look at these two definitions here. We have a constant. We should know this from algebra, but a constant is a quantity which remains the same throughout a given problem or discussion. And then you have variable, which is a quantity that constantly changes throughout a given problem. So that is that. Look at that little paragraph after that. If a variable x approaches a constant a so that the difference between a and x become less and remains less than any assignable quantity, then a is called the limit of x. I'm just pointing that out for future reference. We'll deal with it when we need to, okay? So that was lesson 5.1. I want to take a look at 5.2 as well. We're going to get into some theorems here. Now, we do have proofs and stuff like that. Some of the proofs we'll do, some of the proofs I'm just going to give you a basic breakdown of how these would lay out as a formula and things. And then we're just going to move through here. So we're going to kind of do a condensed lesson, so to speak, on these theorems and things. So let's look at 5.2, area of a rectangle. Okay, we have theorem number 68 here. Okay, put that in your notes. Okay, the area of a rectangle is equal to the product of its base and its altitude. Well, we already talked about this before, that the formula for the area of a rectangle is A equals W times L. Okay, so theorem 68 would be laid out like that. Okay, so that would be how we would describe theorem 68 in a formula. Okay, so we know that we can find the area of a rectangle by multiplying the base and its altitude. All right, I'm not going to take time to walk through that proof there. It's kind of obvious. We already know that. Not really pertinent for what we need moving forward here. So look at corollary 68-1. Corollary 68-1 says two rectangles are two rectangles are to each other as the products of their bases and their altitudes. Okay, so say, hey, what does this mean? Well, this is basically, let me break this down for you. I thought I had it in my notes here. Corollary 61-2. Okay, so we have corollary 68-1. This would break down like this. If I had two rectangles, each rectangle would be equal to, Okay, each rectangle would be equal to the product of its base and its height. Okay, so this is how we would write down corollary 68-2. This is basically how we would lay it out. If we had two rectangles, okay, they are to each other, meaning proportionally wise, each rectangle would be equal to the product of their bases and heights to each other, okay? So that's what corollary 68-1 is. Now, theorem 68 deals with one rectangle, okay? If I have one rectangle, I'm trying to find the area, then that's the formula I use. Corollary here deals with comparing two rectangles, okay? And they're going to be proportional based on the products of their heights and their bases, okay? Let's look at corollary 68-2. Let me find this in my notes here. Yeah, okay. Corollary 68-2. Okay. Again, we're dealing with two rectangles here. This one states two rectangles having equal bases are to each other as their altitudes. Okay, equal bases are to each other as their altitudes. Oh, I did not write this down in my notes here. Two rectangles having equal bases and equal altitudes are equal. Okay, so if I have equal bases and I have equal altitudes. Oops, put the little dash on the wrong one. Okay, so proportionally, if I have equal bases, then I'm going to have equal altitudes as well. Okay, corollary 68-4. Corollary 68-4. Let me get my notes out here. Yeah. Okay, corollary 68-4 states the area of a square is equal to the square of its sides. The area of a square is equal to the square of its sides. So in corollary 68, oh, did I miss 3? I missed 3, I'm sorry. Let's go back to 3. Corollary 68-3. Two rectangles having equal bases and equal altitude. What did I do here? Corollary 68-2, two rectangles having equal bases are to each other as their altitudes. Okay, so that was 68-2. 68-3 says two rectangles having equal bases and equal altitudes are equal. Okay, so if I've got two triangles, okay, they are equal if they have equal bases. So if their bases are equal, and if their altitudes are equal. Okay, so if let's say, for instance, I'm going through a proof and I'm looking and my two rectangles have both equal bases and equal heights, I can then prove that the two rectangles are equal. Okay, so that's how that works. Okay, corollary 68-4. Okay, now this one states the area of a square is equal to the square of its sides. Okay, so this one would be the area of a square, however you want to put that. You can put ASQ or just SQ is equal to its sides squared. Okay, now this one, remember, make note, this is talking about if I'm dealing with a square, not a rectangle. Okay, we know that with a square, the sides are all the same length, okay, whereas that differs with a rectangle. Okay, so this is a pretty basic breakdown here. Let me just make sure I get corollary 62. I mean, equal bases are equal to each other, or are equal. Okay, 68-2 says two rectangles having equal bases are equal to each other as their altitudes. Okay, so yeah, they have equal bases and there would be equal then to each other, like that. Okay, so this is basically the corollaries here in lesson 5.2. I do want to take a note of this stuff at the bottom here. Look below those theorems there. It says it should constantly be kept in mind that the product of two lines means the product of their numerical measures. Theorem 68 is merely an abbreviated form of this statement. The number of surface units in a rectangle is equal to the product of the number of linear units in the base by the number of linear units of the same kind in the altitude. Just basically saying we're talking numerically here, okay? The base and altitude of a rectangle are often called the dimensions of the rectangle. The side of the square is the dimension of the square, okay? Again, you've got your base and altitude for a rectangle because they're different lengths, but on the square, it's just the side, okay? Since the area of a rectangle whose sides are A and B is A times B, the product of two lines M and N, that is M times N, is often spoken of as the rectangle of MN, okay, referring to the area of that, okay? So we would call that the rectangle of MN, and means a rectangle whose dimensions are M and N. That would be the altitude and the base, okay? In positions relating to areas, the words rectangle, triangle, etc. are frequently used for area of a rectangle area of a triangle, and so on and so forth. In the following pages, I want you to note this because a lot of these problems will have the same abbreviations here, okay? So underline it in your book or put it in your notes or whatever so you can find it. In the following pages, R is going to denote the area of a rectangle. SQ is going to denote the area of a square. PL denotes the area of a parallelogram. T denotes the area of a triangle. TR denotes the area of a trapezoid. And RH denotes the area of a rhombus. Okay, so mark those down because that's how we're going to be referring to them in our exercises and in our practices and things like that. That is basically the end of our first lesson here. I would like you to do numbers 1 and 3. And there was one other one I was going to do. Where'd I have it? Let's see. Let's do 1 and 3. And let's do number 5. Okay. So 1, 3, and 5. You know what? No, let's do 1, 3, and 4. Okay. So 1, 3, and 4 for our homework for tonight. All right, now this homework, just like as if we were in class, it will be due to me by the end of, well, let's do this. I'll tell you what, let's make it due, well, no, let's just make it due by the end of the day, okay? So this is for Tuesday, April 7th. Let's have homework due by the end of April 7th. Okay, you can send that to me all the way up till 12 o'clock at night. I don't care. But let's go ahead and do that. Okay. Now we do have a quiz that we've come across here, just in these 2 questions here. I'm going to go over a little bit of that with you in the next lesson, and then we'll determine when we're going to take that. All right. So that is the end of your first at-home online school lesson. If there's any problems or complications, just give me a call or shoot me a text. And I encourage you guys just to be studious, get your work done, and then you can stay on top of things. And I don't want to see your grade drop because we're at home and we don't have someone constantly pursuing you to get your work done. So make sure that you're being cautious of that and that we don't let our grades slip. I'm always available, so you can always shoot me a text or call me if you have any questions. Turning in a half-done assignment and saying I didn't understand it is not a relevant reason, okay? If you did not understand it and I did not receive a text or call or Facebook or FaceTime or email from you, it is a 0, okay, for that assignment. So keep that in mind. Now, some of you were concerned about the extra credit for the 3rd quarter. I still have not determined what I'm going to do for that just yet. We haven't even really pulled those things together, and when I do, I promise you I will give you an opportunity and be gracious there with your grading so that we do not get a worse grade than we would just because we were at home. So we'll work something out for that. Don't worry about it. And as I said, towards the end of the class, towards the end of the class here, we will work on some extra credit and try and pull our grade up a bit by doing that. So just hang in there, guys, and do your homework. Just try and stick with me as much as possible, and we'll get it all done. All right. As I said, if you have any questions, give me a call and or shoot me a text, and we will get it figured out. Okay. Guys, have a good night, and we'll talk to you later. Bye-bye.